Hello, right, here we go with this one, which is lesson 16 for the foundation. We're going to do real life graphs. I might chop this one up into a couple of shorter videos. Okay, real life graph. Real life graphs. Right, let's have a look and see whether it's still going. Yeah, okay, so now you have a water container, and in the water container you're either going to fill it up or empty it, and we're going to do a graph, and this is the depth and this is the time. So just to remind us what this is, the depth and the time, and we're going to fill the container with water at a constant rate. Yeah. So what we would see, because the sides are parallel to each other and vertical, the depth would also increase at a constant rate. So you get a graph like that. Now if you're going to empty it, you would start with the depth being its maximum, and then it would slowly, so coming out there, it would slowly go down, but also at a constant rate. So it would be a graph that looks like this. Now what they do now is change the shape of the container. And again, we have a fill and empty because you don't know which one they're going to ask. And all these are doing is matching up the container with the graph that represents what's going on with the depth of the water. So if we fill this, it's going to start filling quite quickly, but as the container gets wider and wider, it will slow down. The height increase will slow down. So you get something like this. And if we empty it, it starts quite slowly and it speeds up as it gets towards the bottom. We'll change the shape of the container to be like this, and also do another couple of graphs. Depth and time, and depth and time. Right, so the depth, what's going to happen with this one? It's going to empty, oh no, we're going to fill it up first. So it's going to take a long time to fill the bottom, and then it will slowly get quicker. So it will be like that. And if we do it the other way around, it will empty quite quickly at the top, but get slower and slower. So it will be that sort of way. And the only thing they can do there is to make something a bit more complicated. So we have this, and I'll make the graph the same height as the container so we can see which bit's doing what. Now, there's the water. Right. So we're going to fill it up first. So it's going to start slow and slowly increase for that bit at the bottom, like that. And then this bit's going to be a constant. And then this will slow down as it gets towards the bottom. So that would be all one single line, but demonstration purposes I've chopped it up into 3 bits, which is the bottom, the middle and the top. So what happens when we empty it? Well, it starts emptying slowly and increases. Then it gets to this point here, and that will be a constant, and then the opposite will be true. I think that should go right down to the bottom if it empties, but there you go. So that's that. Now, real life graph, all it is matching up the graph to the shape of the container. So I need a graph to go in here now, so that let's copy that, go back, and we'll insert a graph, and there we are. So let's put it over to the left so that we can see. Now this one is called a conversion graph, and nice and easy, a conversion graph. And we'll just do something like this. this, and we'll have kilometers and miles, and we'll go with 10, 20, 30, 40, 50, 60 and 70 miles. And kilometers, we'll do exactly the same up here: 10, 20, 30, 40, 50, 60 and 70. Now what we're going to do is this will be drawn for you, and they will also draw the line that does the conversions. So I know this, so I'm going to just make a little note there and draw the line that goes through there. So this is all done for you, and we could have a question that says convert 20 miles to kilometers, and the other way around, convert what should we do, 30 kilometers to miles. Right, so all you need to do is, we'll do the first one, which is the 20 miles. So find out where 20 miles is, go straight up to the line. Once you get to the line, go left and there, and take a reading there, which is about 34, I think. We'll do that, 34. So we'll do 34 kilometers. And the other way, 30 kilometers to miles. So it's a bit close, isn't it? So anyway, 30 kilometers. So you're going the other way around now, and you go down from there down to there, and you take a reading off of there, which looks like it's, I don't know, we call it 19. Yeah, so that would be 19 miles. Now how about this one? Now convert 200 kilometers to miles. Okay, so again, let's do it in a different color. This one. Now we don't have 200, do we? It doesn't go up that far. So what you need to do is do a factor of 200, which is 50, and draw a line from 50 over there and a line down. And so if we know that 50 kilometers is equal to 30 miles, we just multiply this factor up to get to 200, which is times 4, so that we get 200 kilometers. That one times 4 is 120 miles. Alright, now there's another one of these. Let's copy that, move it down and draw another one for you. And these are another conversion, and so this will be how much? Can't write M's. How much? Okay, so let's draw the there. And again, this is drawn for you, yeah. This is drawn for you. So we're going to have something, an annual cost in pounds. Okay. So we've got one, two. So we'll just go 1, 2, 3, 4, 5. Will be £10. 1, 2, 3, 4, 5. 20. 1, 2, 3, 4, 5. 30. 1, 2, 3, 4, 5. 40. Okay, so this is an annual cost, and on here this will be the number of, we'll call it books, yeah, number of books. So again, 2, 4, 6, 8, 10, 2, 4, 6, 8, 20, 2, 4, 6, 8, 30. Now you've got some information there, so you're going to join the book club. And with the book club you can take out for the price of £10, so £10 a year. Yeah, and for this you can take out 16 books. So for £10 a year you get 16 books. But then after that the price increases. Oh, I'm off the edge there. After that the price increases. Right, and again the lines will be drawn for you. So from 10 we need to go 12, 14, 16, and then I'll just make this second part up. We'll go all the way through to go to there. Okay, so if you take out anything up to 16 books a year, it's just going to cost you £10. But we've taken out 26 books. Yeah, so how much is that going to, 26 books in 1 year? How much is this? Right, so we need to come again to our graph and go from 26 books, 2246, and simply do exactly the same as we've done before. Now 22, 4, do 25, 20, £24.50 I think, so we'll call it £24.50. Yep, that's how we do that. Now let's go over there and see whether we can do another kind of graph. Now this kind of graph is called a distance time graph. Distance time. So again, let's draw all these things in. And explain what that is going to be. So you always have distance up there, and this is a distance from home, and we need to be in kilometers, don't we? Okay, and this one is the time that passes. And so 1, 2, 3, 4. I go up in fours. 1, 2, 3, 4. Okay, so, and the time is 8, 8:30, 9, 9:30, 10, 10:30, 11, and 11:30. Okay, so that's the time on the clock, not the time that has elapsed since it began. Now, so we're going Henry's on a bike ride. Now there are two sorts of ways they can ask the questions on these distance time graphs. One is give you a load of information and you fill the graph in, and the other one is they do the graph for you and you work out what the graph means. You find out the information. So this one, information number one, Henry leaves home at 8:15. Number two, it takes, say, 2 hours to travel. I can't. Hang on. It's a bit too short, a bit too long, that is. I think we better just take 1 hour for this part. Takes 1 hour to go, travel 2 kilometers. I know it's slow. It's very slow. And then part 3 stops for 30 minutes. Part 4 cycles another kilometer in half an hour, and then part 5 returns home to arrive at 11:30. Okay, so you've got 5 bits of information, and then it was saying the questions. Yeah, there's 2 questions on this, so let's just fill this stuff in as we're going along. Yeah, right, so he leaves home at 8:15 there, and it takes him an hour, which will be 9:15 there, to travel 2 kilometers there. Then he's going to stop for 30 minutes, which is half an hour, so from 9:15 to 9:45. He's not going any further away from home, not going any closer, so it's going to be a horizontal line that does that. Next part, he cycles another kilometre in half an hour. So another kilometre will take him up to 3. So we want half an hour, which is that. Yeah, from 9:45 to 10:15. And then he returns home to arrive at 11:30. And there. And there we have completed the distance time graph based on the information they've given us. The question is, what speed, not what did, sorry everyone, what speed did he travel home at? Okay, now for this to work out the speed, which is going to be this journey here, yeah, it's going to be that journey there, so we need to remember our speed time distance triangle. So now we're looking for speed. Speed is distance divided by time. So speed is distance divided by time. The distance home is from 3 down to 0, so it's 3 kilometers. The time took from 10:15 to 11:30, which is 1.25 hours. So that's to be divided by 1.25, changing the quarter of an hour into 25. That equals 2.4 kilometers an hour. Yep. Okay, what's the other sort? What's the other sort we need to do? Is, no, we don't need to do that, do we? So we'll copy that, move down, and another one, and paste. Good, okay, distance travel, we're still doing the same thing. But this way the questions are reversed, as it were. So we still need to go through the tortuous drawing the graph for you. So this is distance from home, kilometers. This one down here is the time. Again, we change the scale now. 8, 9, 10, 11, 12, 1, 2, 3. And 1 kilometer, 2 kilometers, 3, 4, 5, 6, 7, 8, 9. That's far enough. Okay, what we're going to do. So, I'm going to draw the graph for you, and then we'll look at some questions based on what the graph is doing. The last bit I'm going to leave out because we're going to fill that in a second. Okay, what time did, we'll call it about Kenny this time, what time did he get a puncture? Now, he was cycling along quite nicely until 10 o'clock when he stopped, and he stopped for an hour. So this is the likely time he got a puncture, at 10 o'clock, and it could have taken him an hour to fix it. So the answer to that will be 10 a.m. So what time was it when he was 4 kilometers from home? 4 kilometers from home. So what we're going to do, let's have a look. Black. So we're going to go from 4 kilometers from home. We're going to go over to there, and we'll come down just like we're reading all the other kinds of graphs as well. And it's 11:30, isn't it? Yeah, down the bottom there. And so the answer to that is not 10, it's 11:30 a.m. Now, he rode home at 4 kilometers per hour. When does he get home? And then complete the graph. Yeah, because you can't draw the line until you worked out what time. So when does he get home? Now, right, so we need this speed, distance, time thing again, don't we? So we're going to do that and do that. So We know the speed and we know the distance, so we need to know the time. So the time equals the distance divided by the speed. Now the distance is from this point here all the way home, which is 6 kilometers, and the speed is 4 kilometers an hour, so that will equal 1.5 hours, or 1 hour 30 minutes, yeah? Now, from this point here, which is 12 o'clock, 1 hour 30 minutes will take us to this point here at 1:30. 1:30 is the time he gets home, and to complete the graph is you're going to go from there down to 1:30. That's it. And there's the speed, time, distance, and real life graphs for you. And let's have a look at that.